Greeting learners, so we're gonna continue our session. Last time we were talking about the sum to infinity of a geometric sequence. So here is we're gonna have a couple of worked examples. The first one, determine the sum to infinity of the sequence 16 plus 8 plus 4 dot dot for an infinite number of terms. The second worked example is consider the series 16k plus 8k squared plus 4k cubed plus dot dot. First sub-question, for which values of k will the series converge? And number two, calculate the sum of the series to infinity if k is equal to negative 1,5. So we're going to go to the solution. For the first one, determine the sum to infinity of the sequence. Our sequence is given by 16 plus 8 plus 4. So you remember to get the sum to infinity, we're having a formula. Let's start by reminding the formula. Sum to infinity is equal to A over 1 minus R being the common ratio and A the first term of our sequence. So we will start by getting the first term 16 and the common ratio will be R is equal to 8 over 16 will be equal to 4 over 8 and this will give us 1 over 2. So now we can determine the sum to infinity. Sum to infinity will be equal to A. A is 16 over 1 minus the common ratio is 1 over 2. So at the denominator we're having 1 minus 1 over 2. It will give us 1 over 2. 16 over 1 over 2 will be equal to 16 times 2. Remember, when we are dividing two fractions, you multiply the first one by the second one reversed. So we'll be having here 16 over 1 over 2, and this will give us 32. So this is the sum to infinity of this first sequence. We're going to go to worked example number 2. Number 2, let's take it from here. Consider the series 16k plus 8k squared plus 4k cubed plus dot dot. The first sub-question is, for which values of k will the series converge? So remember, we did have the proof of this sum to infinity. The condition was the common ratio must be between negative 1 and 1. So the first thing we're going to try to get here is the common ratio. R will be equal to 8k squared over 16k. This will be equal to 4k cubed over 8k squared. And after simplification here, k squared by k, we're going to remain with k at the top and 2 at the bottom. So our common ratio is k over 2. And then we're going to apply this condition. So we'll be having k over 2 will be between negative 1 and 1. Now, getting a common denominator, we're going to multiply by 2. So we'll be having k will be between negative 2 and 2. So here's the answer for the first question. For which values of k will the series converge? The value of k will be between negative 2 and 2. Then we're going to go to the second sub-question. Calculate the sum of the series to infinity if k is equal to negative 1,5. So we need to get, remember, the first term and the common ratio. So our common ratio here will be R is equal to k given here, negative 1,5 over 2. And then here we'll get negative 0,75. So it's negative 3/4 if we can write this as a fraction. So now we will replace here to get our first term. A will be equal to 16k. That will be 16 multiplied by negative 1,5. Using the calculator, what are we getting here? 16 multiplied by negative 1,5. Then we're getting negative 24. So our first term, A, will be negative 24. So we can now calculate the sum to infinity. The sum to infinity will be equal to A, negative 24, 1 minus, our common ratio is a negative 0.75. And here we're just going to use our calculator, and then we will get the sum to infinity. Negative 24 over 1 minus 0.75, and this will give us negative 96 over 7. So a sum to infinity is a negative 96 over 7. So we are practically done. Our two-word example, the first one, the solution is here, and the second one, the sum to infinity is negative 96 over 7. We are practically done. We are done with the word example. Thanks for watching. Don't forget to subscribe, like, comment, and share the video if you learned something. Thank you. Bye.